Welcome to the Skateboard Learning Task. This is Task 5. In this task, you'll be working not necessarily with matrices, but what we refer to as linear programming. You're going to use linear equations, more or less linear inequalities, to come up with a scenario that would be a benefit to the manager of Skateman. Now, this concept is used. These strategies and procedures are used in business when companies look to maximize the amount of profit or minimize the amount of cost in doing business. So in this task, you'll be considering the fact that there are two types of skateboards: the sporty board, which earns you $15 in profit, and the fancy board, which earns you $35 in profit. You'll want to use some type of combination, a certain number of sporty and a certain number of fancy boards, to ensure that you bring in the most amount of dollars. Now, make sure if you don't understand what this word is constraint. There'll be certain limitations that you must consider when completing this task. But let's get to the basics. I certainly skipped over some information that you still want to read. But I want you to understand that on average it takes a worker 5 minutes to do the sporty board to complete and build one, and 15 minutes for a fancy board. The skate shop is open for 8 hours a day, 5 days a week, so that's pretty much 40 hours. And later in the task, I believe they convert the 40 hours to 2,400 minutes. Now they want to make about 200 of each model per week. They want you to answer the question, how much profit would you earn? And then there are the questions about whether or not 50 sporty and 350 fancy would give you a specific amount, or 350 sporty and 50 fancy. Originally, the 200 of each model would give you 400 boards, and so these two, what could you say, pairings. I wouldn't want to call them pairings, but these two options. I think that works best. Anyway, number 4 asks if you can come up with some type of pairing, a certain number of sporty and a certain number of fancy boards, that will give a great profit, especially with being able to complete those 400 boards. Remember, it needs to add up to 400 in the amount of time that you have in a work week. I'm sorry, that was 4 and 5. So let's get down to some of the basics. So X1, this is more of a production rate for your sporty boards. The X2 is this production rate for the fancy boards. And they look at a Z1 being the amount of profit earned each week. Now don't get bogged down or confused or disgruntled about what the X1 and the X2 and the Z1, what they all represent. I want you to then, okay, certainly read, but I want you to then focus on these equations that are given to you. Now, Z is the profit. Of course, the 15x and the 35x is based on the number of fancy and sporty boards, or should I say sporty and fancy boards that are created. That's for the line where you see maximize. And of course, where you see subject to, we're now talking about constraints. We can only use 2,400 minutes. Okay? Now, the 5x1 says that for each sporty board that's done, it took you 5 minutes. So 5 times a certain number of sporty boards, plus 15, because it takes 15 minutes to make the fancy board. 15 times the number of fancy boards you made has to be less than 2,400, because you don't have any more time. You can't work beyond that. Now you have to remember that you're also using, especially where it says X1, X2 greater than 0, you have to create at least one sporty board and at least one. Well, I'm sorry, you could have none. My bad, it's greater than or equal to 0. So you could have no sporty boards and all fancies, or all fancies and no sporties. Either way, again, the time in this inequality has to be less than 2,400. Here's a beautiful picture, a beautiful image of not only the constraints, okay, showing your x being greater than 0, of course it's being above the x-axis, and your y being greater than 0, above the y-axis, well, above y equals 0 and above x equals 0. So this is all shaded in. Now we can tell where this diagonal line is based on converting this inequality into slope-intercept form. Hopefully this doesn't confuse you. If you were to write it as 5y or 5x plus 5y less than or equal to 2400, and to convert it into slope-intercept form, you would then get a nice linear inequality that you could graph. Okay, I'll kind of tell you what to do. I'm not going to do the conversion for you, although I think it's already done for you. But I would subtract 5x on both sides to get 5y less than or equal to negative 5x plus 2400, and then I would divide the 5 on both sides. So 5y over 5 reduces to just y, because 5 over 5 cancels out, less than or equal to negative x, because it was, remember, the minus 5x on both sides. So again, y is going to be less than or equal to negative x. Sorry, that's a 15. My bad. So I'm sorry, divide the 15 on both sides. So since I did make that mistake, if you want to call it that, I'll go ahead and write that step for you. Just this step, okay? So I would again divide the 15 on both sides, here and there. So negative 5 over 15 is going to be negative 1/3. And 2400 over 15, I'm going to say 160. Now, I certainly didn't divide 2400 over 15 in my head. Again, I did tell you it was already there for you. But here is your equation. It's just that they put the 160 first. Now, in determining what's going to be the best profit, looking at the inequalities that you created, and considering what your feasibility region tells you, you need to then look at this being the number of, I believe that was, which one was it? I can't remember. Sporty. Okay. So this is your sporty number of boards. And here are your fancies. I'm just going to make it a Y. Again, your sporties and your fancies. Now, I knew it was sporty for the X because remember, you had 5 minutes for each sporty. Well, you could certainly do a lot in those 5 minutes versus it being 480 fancies at 15 minutes a pop. Remember, it takes 15 minutes to cut those things. That'd be too much time. So the X value is your sporty boards. The Y value is your fancy boards, if you were to use Y. If you didn't, again, this is your sporty board. These will be your fancies. Now I'm just going to zoom back out to look at what the profit equations would look like. So certainly this would be the profit equation for 3,500, for 0, and then for 7,000. So based on the equation that we first had, which profit, looking at the three values, and I'm kind of referring back to this, based on our constraints, when would we have the most profit? You could certainly have any combination here, but then what would this be? What would that be? What would that be? Plugging in here, there, and there would tell you the maximums or minimums of any value, any combination, any of them. Okay? Now, I'll let you stick with doing all the calculations. Again, sharing your answers with your teacher will certainly open up what could you say, a great discussion about the potential of linear programming. If you have any questions, please be sure to ask your online teacher.